I had a guy who used to work for me, Alex Chepurnoy, and he created this beautiful project called Ergo. To me, that is the spiritual successor to Bitcoin. Ergo is really special because it has the same culture, it has the same mentality, and the technology is kind of like a natural evolution of what you would do if you knew about Bitcoin and you wanted to build the next big thing. So it's still a proof of work system, it's still a UTXO system, but he added UTXO with some smart contracts. It's this Sigma protocol idea. On the proof of work side, Satoshi had this one CPU, one vote idea. So Alex tried to create non-outsourceable puzzles to make it impossible to have mining pools. And there's all these other beautiful little things. And he's this brilliant Russian programmer, and he surrounded himself with all these other brilliant people. He has zero ego. He's like, he has negative ego. When you put him with a person with ego, your ego goes down.
Yeah.
Right. And everything about Alex is always like, how do I solve this? How do I do that? And he gets legitimately excited when he meets somebody that he can collaborate with or learn from. That's where Bitcoin was in the beginning. Everybody set their egos aside, whether it was Hal Finney or whatever, and they would just say, how can I help? What can I do? And it was all about coming up with some cool new thing or solving some cool new problem. I don't see any of that in Bitcoin today.
So quite a few people are excited about Ergo and excited about the fact that you kind of appreciate Alex and Ergo. Do you see Cardano potentially utilizing the proof of work mechanism from Ergo as part of this pool for the consensus mechanism?
I mean, anything's possible, and there's a lot of evolution Ergo has to go through. And Ergo was kind of like when the Xbox 360 first came out. While they were prototyping it, Microsoft needed a development environment. They ironically purchased a lot of Apple computers to do that, because Apple was moving away from the PowerPC to Intel, and Microsoft was moving towards the PowerPC. Just this weird intersection of history. So at that time, the largest order of Mac computers made was done by Microsoft, and they were using it for Xbox stuff. So Ergo we viewed the same way. So we said, well, we have this extended UTXO model. The only thing that's sufficiently close to it where we can beta test contracts is actually with Ergo. And Alex just was a little faster in getting certain things out because we were doing things in a slightly more rigorous way and slightly more expressive way. So we actually tested a stablecoin and Oracle and other things on Ergo. And it has just incredible community. When we said, hey, we're coming here to work and build, oh yeah, we love work with you guys. This is so cool. The other thing is Alex used to work for us, and he had this lovely project called Scorex, and it was all about like a pedagogical framework for building blockchains. And if you want to do prototyping or academic research, it was great. It was super modular, and it separated the consensus network and transaction layer from each other in just the right way so that you can make it modular and mix and match things. So you can put secure cademia in, or maybe a different network layer and a different consensus protocol, like proof of work to another proof of work and so forth. So we loved having that kind of IP sitting around, because it gave us the ability to kind of play around with ideas in a matter of weeks instead of months or years. And then he just took that concept and he gave it away. The Wave protocol was built on it. That was Sasha Ivanov. He did that. And I think there's 2 or 3 other cryptocurrencies that were launched from Scorex. And then Alex took that and built Ergo from it. So there was a nice intersection where there was overlapping technology with Ergo, with our technology. And the other thing was that the community was so open and friendly, it was just a no-brainer. Just go in and start building some things there. Now, in terms of evolving ideas, the whole Sigma protocol idea is very different, and it's very interesting. And there's a guy at Boston University, his name will come to me in a second, who came up with this stuff. And I think there's some merit there, especially as we start moving closer to this idea of blockchains being used to validate proofs instead of running computation.
What's the Sigma protocol, by the way?
So it's just a way of expressing scripts. And basically, you get these concise representations of proofs. And then you can say, okay, the script is correct, but you don't have to run the whole program. So there's a lot. I'm not doing the topic justice. There's a lot more to it, but that's the basic concept. And in a redeemer validator model, you need stuff like that, because as your model gets more complex and a lot more things happen, you don't want to have a situation where I have to replay a huge amount of the UTXO graph to be able to get to a point where I have the state of the system. You need some mathematical artifact that gives you the state of the system quickly, and then you're saying, okay, I now know what computation thread I need to run to be able to get enough to be able to redeem this transaction. So he just found a more compressed representation of it, and the math doesn't matter. What matters is there's a whole beautiful field that thinks about this type of stuff, and it was never once linked before into our industry. The brilliance of Alex was to actually realize you could do that and pull those things together, and it may actually have some merit. but by no means is he the only guy that does this stuff. There's actually other approaches in verified computing that have explored that. Like my favorite came out of Microsoft research is a project called Pinocchio, and there was a follow-up called Geppetto. And the basic idea was that it's fortuitous that you have these computer science problems like hashing, where you can do all this computation, and once you've done all of it, you found this magic number, that you can verify that the computation was done correctly. So the proof of work works this way. Hard to do the proof of work, easy to check the proof of work. Cryptography also works this way. You have some trap door where you can verify something's correct, but to get that thing done, if you're doing it brute force, it takes an enormous amount of computation. Well, not all problems are like this. Like protein folding, to verify the protein is folded correctly, you have to fold the protein. So you have to redo the work. But what if, for arbitrary computation, you could take a problem and then you could generate a proof that you've done that computation correctly, and the proof validates in logarithmic time or constant time? Wow, that's incredible, right? Well, Microsoft actually wrote a paper on how to do that. It's called Pinocchio. So that's another example of these types of things, these roll-ups of things, where instead of doing the computation on chain or trying to create some sort of replicated machine that does all this stuff, you instead just say, okay, only thing I'm going to use the blockchain for is to check your proof. But I'm going to turn it into a distributed computing problem, and any person in the world can do the problem on any server, untrusted server even. Because you don't have to trust the output, you trust the proof, and the proof is deterministic. It tells you these things. So, whether you're using zero knowledge or Sigma protocols or, some other mechanism, it's moving you in that particular direction to turn it from a replicated to a distributed problem and go from I'm doing the work to I'm checking that the work was done correctly.
That's fascinating. And all of a sudden we're back to the P equals NP thing, where for many very interesting problems, the checking is efficient. Is much more efficient than the solving.
Right. And also, do you want complete determinism or is it probabilistic? Because if you relax that requirement a little bit, then suddenly actually you have a broader class of things you can construct this stuff for.